Math Shorts.
We don't think it's any secret that if one were to do any kind of science, they're going to be dealing with a lot of numbers. It doesn't matter whether you do biology or chemistry or physics, numbers are involved. And in many cases, the numbers are very large. Or they're very small.
Mocha. Cacao. Papadum? Eh? But
We are going to steal. Wait! I haven't told you what it is yet. Hey, Dave, listen up, please.
If we're going to ask you, how many atoms are there in a human body? Or the mass of the earth in kilograms? Those are very large numbers. If we're going to ask you the mass of an electron, that would be a very, very small number. So, any kind of science, you're going to be dealing with these. And just an example, let us show you one of the most common numbers you're going to see. And especially in chemistry, it's called Avogadro's number. And if we're going to write it in just the standard way of writing a number, it would literally be written as 6022 and then 20 zeros 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. If we're going to throw some commas in here, it's not going to really help the situation to make it more readable. This is still a huge number. If we have to write these in a piece of paper or if we have to publish some paper using Avogadro's number, it would take us forever to write this. And even more, it's hard to tell if we forgot to write a zero or if maybe we wrote too many zeros. So there's a problem here. Is there a better way to write these? And to answer that question, the easier way to write this is we call scientific notation. Let's do a couple of numbers and we'll just write them in scientific notation. Okay, let's wait. Where did I put eraser thing? Okay, I'll just pick blue. I'm sorry about that. So let's say I have the number 7,300. Okay, 3. Sorry about that. 7,345. Oops, it looked like 6. Wait, 5. There we go. And I wanted to write it in scientific notation. So I guess the best way to think about it is it's 7,345. So how can I represent 1,000? Well, it's over here. 10 to the third is 1,000. So we know that 10 to the third is equal to 1,000. 10 to the third is equal to 1,000. So that's essentially the largest power of 10 that we can fit into this. Okay, I'm just going to write 7.345 times 10 to the power of 3. Okay, what's 0.3 times 1,000? It's 300. 0.4 times 1,000, that's 40. 0.5 times 1,000, that's basically 5. So 7.345 times 1,000 is equal to 7,345. Okay, let's multiply it. Let's multiply it out just to make it clear. So if 7,345 7.345 times 1,000, The way we do it is to ignore the zeros. So let's write 7, 3, 4, 5. Then add the 3 zeros 1 through 3. Okay, then let's, you see the 3 decimal, that's counted. So put it there, yeah. So 7,345 is indeed is equals to 7,000. So let's say I did 0.0000516, and I wanted to represent these in scientific notation. Okay, I'm just going to pick color blue. Okay, I'll go first with a non-digit 0, which is 5. And I'm like, what is the largest power of 10 that will fit into this? So I'll go 1, 2, 3, 4, 5. Okay, that's going to be equal to 5.16. Okay, times 10. Yep. So that's, we counted like it's 1, 2, 3, 4, 5. So we're going to put it negative 5. So okay, I'm just going to pick another color. Okay, purple. Okay, I'm going to pick green. Okay, let's try the other one. 0.000000000. Okay, that's a lot of zeros. 8192. Okay, let's do it in scientific notation. Okay, that's a lot of zeros. So we have to really count it carefully, and let's try it. Okay, the first non-zero digit is 8. So we're going to put, okay, sorry about that, 8.192. Okay, times 10. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and that's going to be raised to negative 10. Okay, I'm just going to box the final answer. Okay, yeah, there we go. Okay, let's say I want to multiply the number 0.005 times 0.0008. This is fairly straightforward one to do, but sometimes it can get cumbersome, especially if you're dealing with 20 or 30 zeros on either side of the decimal point. We can simplify this. This can be written as, wait, I'm just going to pick another color. This can be written as 5 times 10 to, okay, that's 3. Okay, negative 3. And this, that's 1, 2, 3, 4. Okay, 8 times 10 to the power of negative 4. If we're multiplying these two things, this is the same thing as multiplying, it's just the same. So we're going to write 5 times 10 raises to negative 3 times 8 times 10 raises to negative 4. There's nothing special about the scientific notation. It literally means what it's saying. So for multiplying, you could write out like this: 5 times 8 times 10 raises to negative 3 times, wait, I'm just going to erase it, sorry, it's really hard. 5 times 8 times 10 raises to negative 4. Okay, it's okay. Times 10 raises to negative 3. And look at this. Okay, I'm just going to change the color. Okay, first let's multiply this. 5 times 8, we all know that it's 40. And 10 raises to 4 times 10 raises to 3. And if you know the exponent rules, you know that when you multiply two numbers that have the same base, you can just add their exponents. So just add the negative 3 and negative 4. So it equals to negative 7. So, wait. So it's equal to 40. It's, wait, okay. So it's equals to, okay, I'm just going to change the color. So it's equals to 40 times 10, wait, okay, times 10 raised to negative 7. Okay. Okay, let's say we're going to multiply Avogadro's number. So we know that 6.022 times 10 raised to 23. Sorry about that. Okay, multiplied. Okay, let's say some real small sums. Let's say 7.23. Okay, sorry. 7.23 times 10 raised to negative 22. This is really a small number, but the multiplication when you do it in scientific notation is actually fairly straightforward. So we're going to write these is 6.0, okay, 6.22 times 7.23, okay, multiplied by, okay, 10 raised to 23. Okay, sorry about that. 10 raised to 23 multiplied by 10 raises to negative 22. Okay, okay, my voice is really cracking up. Okay, sorry about that. Okay, so okay, I'm just going to change the color. Okay, so we can multiply first this 6.022, okay, multiplied by 7.23. Okay, 7.23. Okay, okay, so let's multiply it. It's 6, 2 times 3, it's 6. Okay, 0 times 3, 0. 3 times 6 is 18. Okay, now 2 times 2, 4. 2 times 2, 4. 2 times 0 is 0. 2 times 6 is 12. Okay, next is 7 times 2 is 14. Let's carry that 1. 7 times 2 is 15. Carry that 1. 7 times 0 is 0, but there's 1, so we'll put 1. 6 times 7 is 42. Okay, 42. Okay, let's add these 6. Okay, I'm just going to write to get different color. Okay, much lighter. 6, okay, 10, carry 1. 4 plus 4, 8, 9. 8 plus 5, 13. Carry 1. 1, 2, 3, 4, 5. It's 5. Okay, 2 plus 1, 3. Bring down that 4. Okay, so let's count the decimal places. 1 through, okay, wait, 1, 2, 3, 4, 5. So we're going to move it 5 decimal places. 1, 3, 4, 5. Okay, so that's basically where the decimal place going to be put. Okay, so let's write these 4, 3. Okay, wait, 4, 3. Wait, sorry about that. 4.35. Okay, it's really hard to use the mouse. 53906. Okay, multiplied by, okay, 10 to the 23 plus negative 22. 23 plus negative 22 is raised to 1. Okay, there you go. I'm just going to back the final answer. So it's, wait, 43.53906 times 10. So there you go. So let's try some examples, more examples for this. Vice versa, we do the scientific notation. Okay, 7.4 times 10 raised to 4. Okay, so we're going to move it 4 times. 1, 2, 3, 4. Okay, 1, 2, and 3. There you go. So 7.4 times 10 raised to 4 is 74,000. Okay, so 120,000. We're going to do it in scientific notation. Okay, let's count. 1. Okay, 1. Okay, wait. Okay, I'm just going to write it. 1, 2, 0, 0, 0, 0. Okay, let's move 1, 1, 2, 3, 4, 5. Okay, that's 5. Okay, so we're going to 1.2 times 10 raises to positive 5. There you go. Okay, let's try this one. 1.765. 1,765. 244. Okay, let's move 1, 2, 3, 4, 5, 6. Okay, let's write these in scientific notation. 1.765. Okay, sorry about that. 2, 4. Okay, sorry about that. 4 times 10. Wait, okay, sorry about that. 10. Yeah, that's much better. Raises to 6. Okay, this is easy. Okay, 12. We're going to write these in scientific. So we're just going to, yeah, it's easy. Going to move it 1. So it's going to be 1.2 times 10 raised to 1. Okay, there you go. Okay, let's try these. 0.000029. Yep. Sorry about that. It looked like G29. Okay. So we're going to move it. How many decimals? Sorry about that. 1, 2, 3, 4, 5. Okay, there you go. So it's going to be 2. Okay, sorry about that. Why did I put 0? 2.9 times 10. Wait, sorry about that. X times 10 raises to negative 5. There you go. Okay, let's try these more examples. Okay, let's try this number 1. Okay, 0.00852. Okay, we're going to move it 1, 2, 3. Okay, there we go. Okay, so it's going to be 8.5. Okay, sorry about that. 8.552 times, how many is that? 3. 10 raises to negative 3. Okay, let's try this. 7 trillion 12. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wait, 11. 11. Okay, 12. Sorry about that. 12. Okay, you moved it 12 places, so it's going to be, sorry about that, 7.0. Okay, that's big. 7.012 times 10. Okay, raises to 12. Sorry about that handwriting. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, that's really have lots of zeros. 5. Okay, let's try 5 times 10 raises to negative 14. 14. Wait, I'm just going to. Okay, negative 14. Okay, that's much better. Okay, 723. It's, of course, it's 82. Okay, let's try 7 times. Okay, it's wrong. Okay, why did I write 7 times? what? Okay, okay, it's wrong. Sorry about that. 7.20. Sorry about that. 7.23 times 10 raises to. I said it's easy, but look, I'm really sorry. Okay, let's try this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's going to be 8.23 times 10 raises to. How many is that? Did we read? It's 10. It raises to 10. Okay, here we go. This is the spot. Okay, we'll just move it 6 times. Wait, sorry about that. 6 times 10 raises to 1. Negative 1. Sorry about that. Negative 1. Okay. Number 1. 5.1 times 10 raised to 4 multiplied by 2.5 times 10 raised to 3. Number 2. Okay. 6.2 times 10 raised to 6 divided by 3.1 times 10 raised to 3. Okay, here's number 1. Let's check. 5.1 times 10 raised to 4 is multiplied by 2.5 times 10 raised to 3. Okay, we're going to multiply these. Okay, let's start. 5.1 multiplied by 2.5 is equals to 5.1 multiplied by 2.5. Okay, let's write there. Let's multiply 5 times 1 is 5. 5 times 5 is 25. Okay, 2 times 1 is 2. 2 times 5 is 10. Okay, let's add these. Bring down 5. 5 plus 2, 7. 2 and 1. Okay, here we go. Okay, 1 and 2. That's the decimal places. So 1, 2. Okay. So 5.1 times 2.5 is 12.75. Okay, I'm going to write it again. 5.1 times 10 raised to 4 multiplied by 2.5 times 10 raised to 3. Okay, Our answer earlier in 5.1 times 2.5 is 12.75. Now we're going to multiply 10 raised to 4 times 10 raised to 3. You know the rules in multiplying exponents, right? You're just going to add those both exponents. So we're going to add this 4 plus 3 is equals to 7. So the answer would be 10 raised to 7. 12.75 times 10 is raised to 7. But this is much better if it's less than 10. So we're going to move the decimal. So it's going to be 1. Let's move it in one place. Okay, 1.275. So the exponent is going to be changed because we moved. So we're going to add 1 in the exponent. So it's going to be times 10 raised to 8. Easy as that. So it's our final answer in number 1. Number 2, 6.2 times 10 raised to 6 divided by 3.1 times 10 raised to 3. Okay, let's start dividing these to scientific notation. First, let's divide 6.2 divided by 3.1. Okay, 6.2 divided by 3.1 is equals to, okay, we have to divide these. Okay, 6.2 divided by 3.1. In dividing, you're going to move the decimal places. So it's going to be 31 divided by 6, 2. Which is going to be 31 divided by 62 is 2. 2 times 31 is 62. And then 0. So 6.2 divided by 3.1 is 2. I'm going to write it again. 6.2 divided by 3.1 is equals to 2. Then we're now going to divide 10 raised to 6 divided by 10 raised to 3. According to the rule of exponents, you're just going to minus the most least exponent. So in 6 and 3, the least is 3. So we're going to minus it in both. So 10 raised to 6 minus 3 is equals to 3. There you go. 2 times 10 is 10 raised to 3. Thank you for watching this video tutorial, and this is Manuela Rojas. Okay, signing off. Bye.